So when a body is taken to depth, so initially it was on the surface. Now it is taken to depth like this. So in this case, suppose if at all it is taken to a depth d, it is taken to a depth d like this. In this case, now the new radius becomes r minus d. If at all the body is taken to a depth d, the new radius becomes r minus d. So in this case, g is equal to gm by r square, that is on the surface of earth, and here that can be changed as g is equal to capital G, m can be taken as a density into volume, and again the r square is here. Density into volume, and again that r square is here. So that's why capital G is here, and density and volume can be taken as a 4/3 pi r cube, because earth is considered to be a sphere. So that's why volume of that sphere is the 4/3 pi r cube is there, and thereafter it is r square, and it is a 4/3 pi g r d. 4/3 pi g r d, this is on surface of earth. On surface of earth, this is 4/3 pi g r d, where r is that radius, and that is nothing but from the center of earth, because all these distance are to be measured from the center of earth only. From the center of earth, it is at a height capital R. From the surface center of earth, it is at a height capital R. So that's why 4/3 pi g r d, this is first equation. Now that is on the surface, it is completed. Now we are coming to this at depth d. In this case, what you have to take here, it is g d is equal to 4/3 pi g r minus d into capital D. 4/3 pi g r minus d into capital D. So in this case, 4/3, again here also that r minus d is nothing but it is the height of that body from the center of the position of that body from the center of earth only. That's why previously it was at r, and now it is r minus d. So now it is a second case, second equation is there, and g is there, and again the gd is here, and after that we are taking 2 by 1. So in this case, gd by small g is equal to r minus d by r, and in this case gd is equal to 1 minus d by r of small g. gd is equal to 1 minus d by r of small g, and there is no any binomial expansion. That's why here only one formula is existing for that body which is taken to a depth. It is 1 minus d by r small g, and d is the depth from the surface of earth. So that's why it is 1 minus d by r of small g. And in this case, what you can understand, definitely here also when a body is taken to either to the altitude or to that depth, in both cases there will be decrease in small g. But that decrease in small g is more in case of altitude. Suppose a body is taken to a height h, and a body is taken to the depth d, and if you want to have same small g value in both cases, a body is taken to a height h, and a body is taken to the depth d. If you want to have the same small g values in both cases, the relation between them is d is equal to 2h. The relation between them, d is equal to 2h. It is very simple. We are equating that 1 minus d by r of small g is equal to 1 minus 2h by r of small g. And from that we can have d is equal to 2h. Suppose if the body is taken to some 1 kilometer height, and if you want to have that same value of that small g, here inside that surface, that is into the depth, the body should be taken to that 2 kilometers of height. There it is 1 kilometer, here it should be the 2 kilometers like this. Then only you can have same value of that small g, that d is equal to 2h is there. And here also when d is very smaller, if you want to find out that what is a percentage decrease in a small g when your body is taken to a depth of like that is a 500 meters or the 300 meters like that. In that case, that is a delta g by g into 100 is equal to what we have taken in that previous case, that is a 2h by r into 100. Here in this case, it becomes a d by r into 100. d by r into 100. So that is 2h by r into 100. That indicates it is a percentage decrease in small g when your body is taken to height. And here it is a percentage decrease in small g when your body is taken to depth. So that's why d by r into 100. Next one, here one point is there. And in the previous case, what we have taken, g is equal to gm by r square, and when your body is taken to the height gm by r plus h whole square. So we have taken that process only. After that, we could apply that binomial expansion. But in this process, we didn't take that. So in this case, we didn't take that process. Here we have taken that is the density only. Density is the factor, and we have completely avoided that mass. And what is the change here? Why it is that change here? In this case, when your body is going deeper into that earth, then the mass of the earth may not change, but effective mass of the earth which is attracting that body will continuously change. The effective mass of the earth which is attracting that body will continuously change. Suppose if at all this mass is taken to this position, here this position, only this part of earth only will attract that body. Similarly, if it is taken to this position, only this part of earth only will attract that body. So that's why the effective mass of earth doesn't change at all, but effective mass of the earth which attracts that body will continuously change when the body is going deeper into that earth. So because of that reason, here g is equal to gm by r square and gd is equal to gm by r minus d whole square cannot be taken. Gd is equal to gm by r minus d whole square cannot be taken. So if you have taken that like that, then m is uniform in both cases. M is the same in both cases, but it is not correct. So because of that reason, we have to completely avoid that mass effect. In terms of that, it is to be transformed into in terms of the density. In terms of the density, and that density of earth, it is considered to be constant. It is also actually not constant, it is considered to be constant. So now that density is here, that is average density of that earth is the 5.5 gram per centimeter cube. So that is 5.5 gram per centimeter cube, that is average density of earth. And in SI system, it is a 5500 kg per meter cube. And actually here also that density may not be uniform, but it is considered to be uniform, that is throughout the density is considered to be uniform. So that's why here that mass is converted into this density factor, and we are considering that density as a constant. And here we have taken only that small g is taken in terms of that distances from the center of earth. From that center of earth, these are the distance from the center of earth. So that's why here we have avoided that mass effect here, because effective mass of that is continuously changing when the body is going deeper into that soil. Next, that is altitude is over. So far altitude and again the depth is over, these are over. So altitude, we have the two formulae. First one is gh is equal to gh by g is equal to r by r plus h whole square, that is the first formula. And the second formula is gh is equal to small g into 1 minus 2h by r is the second formula. And in case of that fractional change in, that is a percentage change in small g, and when the body is taken to smaller heights only, for that we have taken that formula 2h by r into 100. So those are the three formulas that are coming from that altitude. Similarly, when it is coming to the depth, you are having the two formulas. The first one is this one. So here you are taking at depth d, it is gd is equal to 1 minus d by r into small g, and the percentage change in small g when the body is taken to some smaller depths only. Percentage change in or percentage decrease in small g when your body is taken to smaller depths only, and further d by r into 100. Now we are coming to this third effect. So that third effect is, it is nothing but latitude effect. So latitude effect, that's a formula is important, and that formula is g phi is equal to small g into 1 minus r omega square cos square phi by g. So this is the formula. That is a latitude effect. G phi is equal to small g into 1 minus r omega square cos square phi by g. Now we derive how that formula comes. So first of all, latitude. So here in this case, this is the biggest latitude is nothing but that equator, and thereafter that is the phi is equal to 0, the biggest diameter. in that earth is that is the equator, and here that latitude is defined as it is the angle made by the straight line. It is the angle made by that straight line joining the particle. It is the angle made by the straight line joining this particle and again the center of earth, particle and the center of earth with equator. It is the angle made by the line joining. It is the angle made by the line joining that particle and the center of earth with equator, that is known to be, that is the latitude. So in this case, here we are taking that a particle is there, we are considering a particle small m is here, and that is the radius of the earth, that can be taken as the capital R is already there. This the equator is here, and this can be taken as a pole. So this is a polar axis. This is the equator is here. So west to east it is rotating. West to east it is rotating. So it is equator. And again this is the polar axis, is the north pole and again the south pole. So once again I define that latitude. It is the angle made by the line joining center of earth and the particle. It is the angle made by the line joining center of earth and the particle with equator, that is known to be the latitude. So here with equator, that is the phi is here. Now this particle is rotating in a circle of radius. This particle is rotating in a circle of radius, that is a small r. It is rotating in a circle of radius small r. So small r is taken, and this can be taken as the capital R is there. So it is rotating in a circle of radius small r, and it is the capital R is here. And thereafter, first of all, what you have to take, that is a small g is here, small g is always here like this towards the center of earth. Now first of all, what is the centrifugal force experienced by that particle? We have to find out. What is that centrifugal force experienced at the particle means? We have to find out the radius first, and that should be in terms of this capital R. That from figure what you can understand, this the phi is here, this is also phi. This also phi is here because these are the alternate angles. Now small r is equal to, from figure, that is small r is equal to r cos phi. Small r is equal to r cos phi is here, like this. Small r is equal to. Next, now this particle is rotating in a circle of radius capital R cos phi, and because of that there will be centrifugal force. So that is the centrifugal force is here, and that centrifugal acceleration we are taking, that is a centrifugal acceleration, that is nothing but r omega square. Centrifugal force is mr omega square. Centrifugal acceleration is, that is r omega square is here, centrifugal acceleration. So now it is r omega square means capital R cos phi omega square is there. Capital R cos phi omega square is here, that is a centrifugal acceleration. Now you have to take the component of this centrifugal acceleration along this radius, along this small g, because small g will be here, because small g means it is acceleration towards the center of earth. So that's why here it is towards the center of earth, it is a small g is here. Now the component of this centrifugal acceleration, it will be the phi is the angle. So it is CFA cos theta, that is the centrifugal acceleration cos theta. The component of CFA along the line small g, along that line in which small g is acting, along the line where small g is acting, where small g acts. So the component of CFA along the line where small g acts, and that is nothing but, that can be taken as g phi. So g phi we can find it later. So that's why it is r omega square, center component of is nothing but r cos phi omega square, again that cos phi is there, because this is the centrifugal acceleration, that is nothing but it is acting along this line, and the component means it will be r cos omega square, r cos phi omega square, and again that cos phi is also there, r cos phi omega square, again that cos phi, that becomes r cos square phi omega square. Once I tell you. So first of all, here this particle is rotating in a latitude that is phi. Phi means how do you define that latitude? It is the angle made by the line joining. It is the angle made by the line joining the particle to the center of Earth with that equator. It is the angle made by the line joining the particle to the center of Earth with the equator, that is known to be the latitude. And here this particle is rotating in this circle, means you have to represent that smaller in terms of that capital R, that should be r cos phi. And centrifugal acceleration is, that is r omega square and r cos phi omega square. The component of the centrifugal acceleration along this line where small g acts, along which that small g acts. So that is r cos phi omega square, and again the cos phi is there. So r cos square phi omega square. Now that is g phi is equal to, this we can consider it is g dash. We can consider it is g dash. G phi is equal to small g minus g dash. That is small g minus g dash. So that's why g is here and minus g dash is r cos phi, cos square phi omega square is there. So therefore g phi is equal to small g into 1 minus r omega square cos square phi by small g. So this is g phi is equal to small g into 1 minus r omega square cos square phi by small g. So this is it. And we have two cases here. The two cases are, suppose at equator, we can take it is phi is equal to 0 degrees. Why? Because phi is equal to 0 degrees means at equator this line doesn't make any angle with that equator. So that's why phi is equal to 0 degrees. Therefore GE is equal to G minus r omega square. And at poles it is taken phi is equal to 90 degrees. 90 degrees means this line that makes an angle 90 degrees like this. So that's why GE is equal, GP is equal to small g. That indicates definitely that acceleration of gravity is maximum at poles and minimum at equator. And minimum at equator, so far we have completed that in case of that variations of small g, that is effect of the altitude, effect of that latitude, and again that effect of this effect of that altitude and effect of depth, and thereafter effect of this latitude. So these are, and we can continue in the next class also.